on YouTube. I'll give a shout out to all the guys that are putting in the comments. There was a question about 2-18 with those 30-degree ellipses. If you've gotten to it already and followed the video, the most common question is, where did you determine that a 30-degree ellipse is half the major axis as the minor axis? Well, I did a search. I found techdrawingtools.com here, and they have this nice chart that as you rotate an ellipse about its axes, then pretty much the 30-degree ellipse is 50% of the vertical scale. So whatever your large number is, your major axis is, the minor axis is 50% of it. All right, and then as you go and rotate through those other ellipses, that gives you the scales for those other items. All right, so by definition, a 30-degree ellipse, 50%. So we'll jump out of that one. And I never got that information. I was thinking, wow, I would like to break out the algebra and the trig to figure that one out. But I kind of cringed at it and said, well, we'll save that for a nice Saturday afternoon when, I have math on the brain. The other issue that is, for whatever reason, this is one of those semesters that I don't know if it was the install, I don't know if it's something that I told you to do or didn't tell you to do. But that whole, I'm going to stay with the standard part templates. We'll run through that one more time as well, just to revisit a few topics before we jump into our project. Under the tools and the sketch tools settings, right now, I guess I'm not in a sketch. All of these should be highlighted or checked. So maybe because I'm not inside of a sketch, so let's double check. I'll just open up a sketch real quick. Tools, sketch settings. So automatic relations, automatic solve, enable snapping, shaded sketch contours. We added that from the command search. Probably don't want to lost it. Probably don't want to detach segments on the drag. What that is it's going to break your relations and allow you to remove a segment. So maybe not that one. Override dims on drag and move. That's kind of what Instant 2D and Instant 3D do. I would rather you get in the habit of the modify box, going in and putting in a dimension and having it update like it's supposed to. All right, so I will kick that one out, that sketch out for just real quick. We ran through the process of setting the things that we like. So turning the origin on. I want my template to have an isometric view to start. We set our default, and so the plain white. Went through, set a couple of options for units. So I'm going to give you like the 3 or 4 big ones that you would want to change. All right, so inch units to 3 decimal places. And then we hit OK. There will be a few more that you would want to build in. But then you're going to go File, Save As, and under the Save As type, we'll go to Part Templates. And Part Templates will take you very deep into the Solidworks folder. If you're on your laptop, if you're on your desktop, then that's fine. That's okay for location. You're going to be able to get to it. If you're transporting, all right, so you're going to use this on computers, your work computer, or you're on a network where you may log into one station, go to another station, and want to have access to those items. Then that is where we were putting it on the flash drive. And in the flash drive, I just created a system folder and saved my templates into that location. But we have to then, under the options, make sure that our file locations, which I wanted to check, mine's still pointed to E drive, so I hope that's E drive. Well, it came up, so it was E drive. So I added that location. If that location is not in your options, or the computer resets, then or you plug in 2 flash drives like I just did, and the first slash drive grabs Z and the second one becomes F, then this would tend to fail. All right, so this Z concerns me enough that if I wasn't getting my templates off of the drive, then that would be one of the locations that I'd go look. So the last video we went through a little more detailed on setting up the part templates, but you should probably have a part inch and a part metric to work from. My problem is we do so much part inch that I always forget to grab the part metrics, and I'm into the sketch and I look down and I'm in metric or in inch, and I have to change it anyway. All right, so the YouTube videos then. Several more questions came in about the drawing. So this is the 1940 second edition, and we have a nice bill of materials, which is pretty cool for having the information. And then this was the drawing. So I will give you your choice. Would you rather do this one or the isometric views that we're working from? All right. So a little busy. That would take a little bit to decipher. You've got your right view, you've got all of your assembly view, everything in place. Yeah, interesting drawing. That took a lot of work. That was a big sheet of paper too, I imagine. All right, so we're going to go down one more, which was, what did I call it? Yeah, this one was the first edition. So why they went from the first edition to the second edition, I put the second edition, of course, for shock value. First edition then is, let's go ahead and go to fit with, and notice the date's April 21st, 1930. So I was telling you in the 50s, I was still off by about 20 years. So we will refer back to this one if we get into trouble. And, oh, I like the X this out, that no longer applies. And those are kind of cool. So you've got revisions in place. Didn't notice that one before. So, and then the last one was just details and instructions for the mix of parts. All right. So if I will work on getting that fully annotated and verified so that I can put it up on Canvas for you, so you can have it as reference. The other one was looking for the connecting rod. So in the 5th edition, and this one I did not get annotated yet, in the 5th edition I found this one, which that looks pretty cool. That's got some good geometry on it. I don't know if it's the same size, so it'd be, well, you know, hope it fits. And then I went to one of the earlier editions had a note that said, go find this drawing. And one of the issues here is this has a trademark branded logo. All right, so I will not be reproducing that logo. It falls into the realm of public domain or into the publishing, showing it to you, but I'm also going to leave this up long enough that if I have to take my little block of video and make the logo go blank, that it won't be very painful to modify my video. All right, so forging, and then machined, and then assembly. So when we start talking about forgings, oversized material, anything that's going to be ground. All right, so and then also when you get into coatings, are we going to take into account build up for anodize? Even chemfill, very light coating, but it's still going to build up your surface area or your material, even though it's going to reduce oxidation, reduce corrosion, reduce those types of things. All right, so we'll get back to the one we've been working with. Let's see, what was the other one? Powder coat, not so much, because powder coat is fairly consistent, but because it's kind of a spray, you're going to have maybe not as consistent thicknesses that, you know, if you're going to use it as a wear surface, I don't know, probably not the best wear surface. I mean, it is hard, it is good protection, but you're not it depends on anything that depends on the operator to put it on consistently and smooth is probably not something that I want to put hey, we're going to build up 10 thousandths and it comes in 50 thousandths, right? Or a big glob over here and a little thinner over there. So, all right. Oh, I forgot to ask you. Any questions on the assignments or the track 1 assignments? Okay. Well, I'll take those in lab if you have them. So, item 7, following the pathway around, and then also using the other 2 drawings that were there. Item 7 is pinned in place for item 8 and number 39. So we come over to item 8, which was the handle and hand lever. I think 39 was just the 1/8 inch by 1 inch long pin. So this has that little off angle, but when I look at this, I see a boss with the geometry going through the center, and then pretty much that 30-degree angle. While the intersection is interesting, it can be pretty much just a revolve. All right, so if we break it down into its components pieces, this really isn't that bad. All right, so this will also be our first introduction to an assembly. I have 3 pieces here that I need to do something with, so they're not overly complicated, but we have to go through that process. So we're going to tackle the hand lever first. And we'll fly that out of the way and jump back into Solidworks. We'll tackle the hand lever first. The pin we will pull out of the toolbox, and then the other cam or the screw feature, we will pick that up at the last. All right. So when breaking down these larger top level assemblies into sub-assemblies, we kind of want to find the mix and match that seems appropriate. 3 pieces, well, 2 pieces is an assembly. If I may add something to it later, 1 piece is an assembly. It just kind of depends on what my design intent is. So we make those decisions go along. On the upper end, probably somewhere between 15 and 20, maybe 25 pieces, you will find that makes a sub-assembly. There'll be a point where 1 more is too much and 1 less isn't enough. And you keep adding things, and wow, this is getting really cumbersome, and all of the mates, and then it's just time that this doesn't quite fit over there, and you start breaking it into categories and groups, and this would be better over there. And maybe it is a mid-level part that attaches to a sub-assembly and another sub-assembly. So you're always juggling information. All right, so my fingers went ahead and got me right-clicked on the top plane, went up to the little icon, and selected Open the Sketch. Since it was on the top plane, it automatically started, and we'll go into the circle command. And the circle, let me zoom up a little bit on this. And so off screen here. Okay, see the height. Oh, there, no, that's the width of it. Oh, right there is a mark, 1 inch. All right, so 1 inch. All right, then the question becomes, do I go ahead with the extrusion, or do I put the, let's see, what would that be? I would call it just the broach, the intersecting, the mating geometry to the screw. Do I go ahead and put that in the same sketch? Well, this is simple enough that there's not a real reason, and probably not going to change. The issue here is with the angles knocked off the sides. This is going to have to be broached. We're going to have a round tool that goes in here, and either these are going to be really big radiuses or really small radiuses with a bunch of broken, very small tools. All right, so we put that angle in there. Then, yeah, the other option would be, okay, I'm going to wire EDM these. Well, not in a mass production environment. we're going to have a broach ground up so that I can push through there and have all that geometry pretty much generated from the, let's see, 4.5 inch. Yeah, we'd probably put the 7/16 437 hole through and require the broach and steps to remove the rest of the material, make it accurate. All right, so as you're going through the design, a little bit of the manufacturing, kind of looking ahead. What are going to be some of the issues with? Are we making 1? Are we making 10? Are we making 100? Or is this going to be what the company makes for the rest of its natural life? All right, so 0.43, 7. So 7/16 rounded down. This is always going to be square, so I'm going to do the select, control, select. Right, so right now the sides are in blue. So when I pick any of the other two sides, so select with the left button, hold down the control button, select with the left button again, and we're going to set those to equal on the pop-up. And over on the lower left, right about where my timer is also the other equal. All right, so because we're given a 1/2 inch across the flats, do we go ahead with the contour and region, or do I try to set a chamfer? All right, we could set a chamfer the 45 degrees, but there is also such a thing as a 3-point center rectangle that when I drag off in, well, let's make it a little bit longer. When I drag off in the direction, I get part of it. Oh, didn't want that one. And then I can bring those back to size. So select, control, select. Those will be equal. And no, not 90 degrees. So it escaped. No, I'm not ready for that dimension. And 0.5. And then if I've done that correctly, then one of the center lines should be horizontal or vertical. All right, so now I have those intersections. The question is, do the center lines play a part? And let's go ahead and make the selection. This is 3/4 of an inch in height. So extrude. The option is, do you want to trim? We can go, well, jump back over to Sketch real quick. We can go up to Trim Entities and start clicking and trim a bunch of items away. But I can also just go into my definition, and because I have the contours and regions, this, let's see, that one stays, that one goes. Okay, so once I figure out which ones I need. Alright, gotta look down on it. So Control 5 to go to the top. So that one goes away, that one goes away, that one should go away, and that should go away. And that left me the rectangle. Oh. And the corners. Might have been easier to trim. Alright, but that gives me the shape with all of my geometry remaining existing. Go ahead and select it. And the difference here will be the sketch icon. Instead of that standard sketch, we'll show the little poly whatever with the circle in it that tells you that you use contours and regions. Right, so mainly we use regions here. All right, so let's go with the front plane. And I'm going to zoom back out a little ways. One of the other things that came up was as you're zooming, keep in mind that when you're zooming in, you are following the part. Zoom is around the mouse. So zooming out, probably not as much of an issue. Or sorry, zooming it smaller, not as much of an issue. But as you keep the mouse stationary, the part's going to zoom around it. But if I chase that part in, I'm going to be able to track it and get it in geometry. It's also how I'm kind of doing the weird pan without having the pan up, is I just kind of keep moving the mouse over away from the part and then part closer. And other than that, I just like to play with the middle mouse button. Alright, center line. And we're going to start with the revolve. Well, let's go without the center line. Let's put the geometry in, and then we'll see what we get. All right, so I'm looking for the midpoint. Even though this is a cylinder, the plane that I'm drawing on intersects that cylinder. So the projection of that edge into my flat plane, even though the cylinder has curvature, is going to be that straight line. All right, there's two ways to navigate. So right now we've got coincident in the midpoint. The other one, depending on the function, you may see the silhouette edge. All right, so I'm going to bring that out a little ways. I want a tangent arc, so we did some continuous arcs. I go back to the start point and I drag the direction that I want it to go, and it does the continuous arc back into line. And then if I don't at least intersect this line somewhat, if I were to stop here, I'm going to end up with a gap on the bottom side. Now, if I had drawn this on the bottom side, that might have been better. Oh, it went back to construction for me, so let's switch that one back. But I've already committed, so we'll drag that one in. All right, so basically connecting the dots, and then that one's able to move. So here's a spot where we can go to collinear. All right, and then that one moved, so we will go parallel. So everything's kind of an observation of how it moves, how the blue dots are able to, we're able to pick up that geometry. We're going to react to it. All right, so going across the top, I'm going to do hidden lines displayed. All right, so back to the front view, Control 1. I'd rather not set a dimension if I don't have to, so if I were to make that coincident, then even though this is able to move and potentially change shape, I won't ever intersect that opening that I left. All right, I put it right on the edge, and that may be a good plan. It may sneak up on me later, but for now, we're going with the angle. Oh, the endpoint was selected. When you go to select for angular dimensions, you're picking between two non-parallel lines. All right, so in this case, I can use the base of the part, go up to the what's going to end up being my center line, and we'll set that for 30 degrees. All right, so it doesn't look too bad. What did we have for sides? Oh, they're saying there was an 1/8 inch from the bottom. Well, then I think I went the wrong way. So we'll see what it measures and come up with a less complicated way. All right, so spherical on the end, 1/2 inch diameter, no center line, so I'm doing math. So 0.25, and the overall length. And will that be tangent? Yeah, in theory that should be tangent. So from the center line, from the origin out to our point, we'll go 6 inches. Wow. Wow. That was a lot bigger than I expected for a handle. 30 degrees, 1/2 inch diameter. No, that's about right, 3/4. All right, so I do want to set one more point since I did go the wrong way. I did not catch the 1/8 inch geometry, so we're going to see if this misses or if it actually settled on the midpoint. All right, to make this revolve then, we don't have a center line. I could apply a center line, but geometry is simple enough that It's not absolutely required. It's probably a best practice to put in your center line. We're going to go with the revolved boss base. Since there's no center line, you have to pick the axis of revolution. All right, so when I pick one of the lines, we're going to see the start to see the preview. 360 degrees. Yes, we want to merge the result. So they're saying that this is going to be forged. So this would be a single piece in one stamping or one forge, and then we would come back and finish the center. Maybe have to clean up or polish the end. All right, so not quite 1/8 of an inch. Yeah, not going to fight it. And as large as that is, by the time we put the radius in, and no specific radius called out that I can tell. So, oh, we have one more to put in. So the 1/8 inch dowel pin hole will just go into the front plane, and keep in mind that the front plane bisects the part. All right, so when I draw this on the front plane, we have an 1/8 inch hole, and we had the kind of the discussion of when to use the hole wizard and when to just go ahead and make it a cut extrude. At this point, my best guess is that this probably isn't going to turn into a countersunk hole. It's not going to turn into a counterbore. Probably not going to be threaded. So with that in mind, we'll go ahead and push this through. And worst case, I decide that I want it to be countersunk, counterbored, or threaded. It's not that big of a deal to go back and suppress this geometry, delete this geometry, and go ahead and change it to a hole wizard item. All right. So we're in the center of the part, and through all would go one direction. Through all both is activates direction 2 and makes it through all awesome. So now it's going to go through both sides of the part. All right, and because this is a cranking mechanism, going to keep this locked in, we're probably going to press, do a light press on this this pin anyway, and make this a single piece. All right, so we go ahead with the through all both. That gives me the geometry. We can switch back to the solid. Real quick check, since I don't see the radius, but we have a radius in there, so the fillet. No preview, no fillet. All right, so let's see what a 16th looks like. So 0.06, hit tab, still no preview. Well, you know, it was 1/8 of an inch, 0.03. Oh, actually it said no preview. Let's do the partial preview and see if we get something. Ah, there we go. That helps. So I didn't realize my no preview. My partial preview or full preview is always set. So let's go back up to the 60. So I might make it all the way around. All right, interesting little flat. You know, as the cylinders come together, not as impressed. So let's go back to 30. Much cleaner. All right, so we could find some value in there that looks okay. So we're going to save. All right, I'm at decision time. We have 40 some odd parts. There's going to be 3 parts in this subassembly. Can I keep track of them? Yeah, probably. Best practice, though, is going to say anytime I create a subassembly, I'm going to at least think about creating a folder for that subassembly. So we can go new folder, and this will be the handle, or hand lever, or well, we'll just do a handle, and item 8, and hopefully this will open up some opportunity for our data management a little later. All right, so there's the hand lever. I'm going to go ahead and leave that open, and we'll fly this back in. reduce it back down where we can see it. All right, and then item 7 over here. Okay, so 5/8 diameter, heat treat B, 1/2 inch 12 again, and we're going to stay with the 1/2 13s. 1/8 inch in place, everything else pretty much standard, 2 1/4 on the length. And then we talked about this little broken out section showing for the 16th by 45 degrees chamfer on the end of the part. Main question here is to thread or not to thread. We're going to start with cosmetic threads, and we'll worry about the thread function and the swept cut threads a little later on. All right, so let's fly that back out. We'll have a new part. Okay, so I have the template set up. I'll go ahead with the template, and let's no real reason to do this as a revolve. One of the things I might do is, looking into my magic crystal ball of design intent, is I jumped into the front plane. Since the orientation of my hand lever was kind of in the top plane, I might want to consider making this in the top plane. But that takes all the fun out of the assembly, so we want to at least have something to manipulate when we take it into the assembly and set our orientations. Alright, so we're going to go ahead with the 1/2 inch. On the diameter, extrude boss base out to 2.25, and I kind of like my Z's to go the other way, so I'm going to reverse. And that's also going to help a little bit, maybe not much. Front plane and face both are good. All right, so we'll go with that geometry. We have the 7/16 by 7/16 relief. So I'm going to go back to the center rectangle on the end face and drag out my center rectangle. Highlight, so select Control Select, and on the pop-up we'll go equal. And then the dimension, jumped in the dimension. For my selections were clear, 0.437. And that's going to end up being a cut for 3/4 inch deep. Alright, so I really want to remove this outside section, and when I go into the features for the extrude cut, we're going to have this ability, 0.75, if I don't cover it up, to flip the side to cut. Right now, the material inside of that region is what's being removed. As soon as I tell it to flip side to cut, everything outside of what I've created cuts. So I can remove those the little fingernail shapes out of the geometry by flipping that side to cut. All right, so that makes it at least a little interesting, because the 1/2 inch was at radius, and I'm pretty sure that didn't say diameter on its 1/2 inch. No, how about that? It did. Oops. All right, so we have a correction to make, or I have a correction to make on the other item. Well, let's leave that as an interference so that we can see it in the assembly, and then we'll make the correction because I put the angles in there. All right, so we'll go ahead with our pin geometry. So again, the 1/8 inch diameter. 3/8 of an inch from the face. And let's see, they are calling that, they're calling it a drill in place. So they're talking about assembling it. If we're making these in any kind of production, we need to account for a little bit of clearance on the depth of our notch, and allow for some variation so that we don't really want to drill every one of these in place. At least I don't. Okay, so through all, and we'll set for the pin. All right, I do want to create a call out for the thread, and the thread designation was the 1/2 inch 12, and its length. So there's about 1/4 of an inch of gap between the edge. All right. So cosmetic thread or a simplified thread form, we're going to pick that leading edge, and then it is insert. Let's see if we're going to find insert. All the way at the bottom is annotations, and the annotation that we're looking for is cosmetic thread. Cosmetic thread is what the hole wizard does automatically. Since we're on an external, we have to give it a little more information. So start from face or plane. Well, we pick the edge, that's fine. The standard can be ANSI inch. If we had to have this 1/2 inch 12, then we would put in additional numbers and make the adjustments ourselves. Since the 1/2 13 is in the standard, we're going to stay with that 1/2 13. All right, and then it's a blind in condition for 1.75. Nope. 1.25. Okay. And then the thread call out will pop up in the drawings more as a reminder than what we'd want to use. We can see the minor diameter on the end when you go normal 2. All right, so control 1 at the face. You'll see the minor diameter is dashed lines, and then of course the major diameter. When we go to a side view, then you'll see the simplified thread form. All right, and then under whichever one created that geometry, probably the boss extrude, if we need to go back and edit, you're going to expand out and be able to identify that cosmetic thread. And then just like any of the other features, edit the feature takes you back into the property manager. Now we could change it to a 1/2 20 or to whatever thread we need it to reference. Last is going to be the chamfer. And so we could have drawn, well, if we had made a revolve, we could have drawn the chamfer into the mix. But since we didn't, the last feature then under the features tab, we'll come about halfway over, find the fillet, chamfer is embedded under the fillet. Let's see, different styles of fillet, and I'm trying to think, 2018 also gives you the option, I'm not sure if it goes both ways, but to go from a fillet to a chamfer based on the same selection. So we're not quite there yet. And said it was a 1/16 of an inch, so 10 millimeters, a little on the large side, 0.039 or 0.3937. So we'll go with the rounded 0.06. That looks pretty good. And go ahead and accept. All right, the cosmetic thread may push back just a little bit, but we'll have enough detail when we create the drawing to designate what those items are doing. All right, so this is item 7, stud, and save. Okay, so the pin, I could draw the pin, but I have a full library of hardware and fasteners. Pins, socketed cap screws, hex heads, all of those already exist. I want to check and at least make sure that I don't have one before I start drawing it. Alright, so we have our 2 items open, and I did not create an assembly template yet, so we're back to the standard templates. And so our 3 modules, the part, the assembly, the drawing. When I pick on the assembly, it's going to look very similar, except it's going to start asking me things like the create layout. No layout, not yet anyway. So we can collapse that one, give us a little more room on the screen. Here are the 2 items that are open. if I did not leave one of the part files open to be able to grab it, then I would have to browse back to that folder, or if it's not in the part that I'm looking for is not in that list, then I'll go navigate to that item so that I can bring it in. All right, so we want to, under the options, start the command when creating a new assembly, automatic browse when creating new assembly, and graphics preview, yes. So if you hover, maybe not with this graphics card. Some of them, if you hover, you'll get a preview. No on the virtual, no on the envelope, and then yes on the rotate and context toolbar. That'll come in a little bit later. All right, so when I pick the hand lever, and we're just going to do the one, there are, what, 5 or 6 ways to bring a part into the assembly. So we're just going to use the property manager at the insert. So the rotate comes in here at the bottom left. I think my orientation is going to be okay, but notice that as I'm moving around the work area, then the part is following the mouse. When I come over to the checkbox, that's going to place the origin of the part on the origin of the assembly. And it's also going to fix its location. All right, so here's one of the places where I'm okay with fix. So we get an F out in front of the part, or the instance of that part, that says that if I try to drag it, nope, component is fixed, it cannot be moved. All right, it's the first part. When I go through my my views, Control 1, 2, 3, 4, Control 5, Control 6, Control 7, Control 8, all that looks good. Well, Control 8 looks a little weird. Oh, that was normal too. It's normal to a cylinder, so never mind. All right. So we have the location, and then I will jump over into the assembly tab, and notice that we can still do sketches within the assembly, but they're not going to directly create features. So really, in the part is where we're generating the geometry, where we're going through. There are some additional functions that we can do out of the assembly that require sketches, but keep in mind that we are in a separate module. All right, so when I go back up to Insert Component, the stud is available. Zoom up a little bit. I don't really like its orientation, so that rotate. If we rotate about X, well, that almost did it. So a couple more rotates, and I can get it pretty close. All right. Otherwise, when this comes in, I will have to manually. Now the pins aren't aligned, but I'm going to leave that one so that we can manipulate it a little bit further. So wherever I place this, that's pretty much where it is. I go back to the front view. It's left click, hold down. It can move every which way. I can sort of line it up, but when I go to the top view, it's going to be off. I can line it up a little bit closer this way. Not quite. Getting there? Not really. All right, so this is where the mate relations come in. So the terminology that you're learning in the parts, the coincident, the concentric, the handful of relations, that terminology is going to stay consistent so that, for the most part, coming over the assembly is not a big jump. All right. So since the pins need to line up, that would be a good place to start. We have the paper clip in the upper left. And the paper clip is the mate relations. All right, so I'm going to start off with the pin, because that's kind of a critical piece of geometry. I would like to see its interference. And then I'm going to control select. All right, when I control select, just like in the sketch, I get the pop out, and I see a bunch of very familiar symbols. Okay, so we're getting more familiar symbols. All right, if I don't do the select control select, then we can go right into the mate. And out of the mate, the property manager, since I have the blue box, I don't have to hold down the control button. So a little bit of advantage picking the paper clip. My workflow is I'm big on pre-select, big on the control button. So a lot of times when I slip into slip into my assembly mode, it is all going to be pre-select. And then once I'm in the property manager, we'll go ahead and pick. All right, so cylinder to cylinder in this case, and then it rotates into position. And we'll go ahead and accept either from the pop-up or from the property manager. Go ahead and hit OK. All right, still able to rotate and interfere. So any of the other assembly videos that you may have watched me do, you are responsible for two objects occupying the same space. You are responsible for gravity. You are responsible for power, oil, air, if it is pneumatically, hydraulically powered. And if there is electricity, you're even responsible for the electricity. Right now, it's just floating in virtual space, and it is waiting for us to tell it this, what to do so that it is not an interference. All right, so we went to the concentricity first. My next selection would be, let's expand out. So the little flyout goes to the assembly. I can see the instances of those parts, and I would like that looks like the, nope, maybe, top plane would be okay. The top plane and the right plane to be coincident. Well, not exactly coincident. All right, well, this is one of those cases where if I needed to change this, if I needed to update its location, I really don't want my geometry to error out on me. So in this case, I would go parallel. It achieves the same function, but downstream, I may avoid an error later on if something happens that those planes can no longer be coincident. All right. Plus, we don't use parallel all of the time. So anytime you see a parallel pop up, it's kind of a unique. It's one of those. It's kind of a flag. You'll be able to identify it pretty readily. All right. So my hierarchy is going to be plane to plane. So the plane of the assembly up here to some plane in the part. And if the planes are not convenient, or I have better selections, then I could go plane to face, face to face, and then less on my hierarchy is going to be edge to edge, and even less is going to be point to point. All right, we can provide those functions, but each of those has kind of an additional can cause problems later on. Edges, when they work well. When they go away, they're really a pain to chase. All right, so on our size, we can try the face-to-face, and we'll see if that does anything. So select, control select, went to the pop-out, and coincident. All right, so when we look at this, well, the half-inch by half-inch, if we were to broach those at the angle, let's see, did I get an end mill in there? I still don't think that I can get that corner to go to a radius with any kind of size. I mean, the flats, we're going to have to drill a 7/16 hole, and then some way come in, round off the corners, and the half-inch that continues on through here. All right, so I can see light. So the chamfers, as opposed to the round, if I was having a broach ground up, would I rather have it be the round corners or the chamfer? That's a good question. I'll have to ask my tool grinder. Which is going to cost more? To take a circular broach and put the flats on it, or take the square broach and put the rounds on it? All right, but the main thing is that with the gaps, this is still a relatively tight fit, and there's enough contact surface over there that I'm really not concerned. But we want to go back and we identified an issue. We want to go back and make the update, make the change. So I want to quickly, even though I know that the stud is open, I can right-click and open part, or I can come over to the window and switch windows. All right, so actually that was the one that was okay. Had the correct geometry. Go to the hand lever, and we'll go back into our edit sketch. Well, one of those has to have the dimension on it because I'm expecting an error that tells me, okay, if I didn't just lock it up. Parts are saved, the assembly, not so much. Alright, so where is my... Oh, pesky second screen. Let's fly in the air. There we go, found it. Sketch confirm delete is, yes, I want to delete an object that has a dimension associated to it. And then we can go ahead with the delete. So I change this back over to the circle, make it the ½ inch, and accept. Except we're going to get an additional warning. None of these are like deal killers. There are going to be a few things that maybe do lose its definition. So let's check. All right, so within those regions, let's see, bring that out. That all looks good. It found the circles removed. It still has the flats. Oh, I guess it was selected. Nope, there it is. It was more circular than square. So let's go normal to Control 8 and make sure that our fingernails. No. Yeah, I can't quite see the preview on that one. Okay, well, when all else fails, clear the selections. And we'll try to make them again. And almost, it's still trying to make the round. Okay, I may have bitten off just a little more than I can chew on that one. Okay, highlights, alright. Oh, that should have been a remove. And we still have the little bit of fingernail coming in there, so. Alright. So out of those two, which one would I want to keep? So that one goes that way. That one will remove on the corners. And that should have stayed included. Are there any edges? Okay, so one contour. Okay, I think that contour was the culprit. Alright, so since I was picking regions, the contour is out of sorts. And the flat came back, so the intersection came back. Alright, so the revolve, we'll edit its sketch. Anything that is in amber is going to be is typically going to be the issue. So where that was related coincident, I need to get rid of that relation, amber, amber. All right, and I can immediately reapply it. Coincident? And it's not going to hurt anything. It just lost that face. It can't recalculate based on the change in geometry. So I have to update it. All right, so if we did all of that correctly, I can close a few of those out. We have the stud. And now I have pretty much a line-to-line fit. So no gap tolerances, no clearances, no tolerances. So at that rate, it's almost a press fit. All right, so inside of, let's go ahead and save this since, and we'll come up with a hand lever assembly. All right, and within the add-ins, you can go up to Solidworks Toolbox. Under the options and the add-ins, there are two toolboxes. All right, so the Solidworks Toolbox library is actually the one that we want. The Toolbox Utilities is a set of tools to help you calculate beams, weld profiles, or structural steel profiles, external, internal retaining clips and O-rings, things like that. Also, if we expand out, highlight the toolbox, it says, oh, it's not added in. Would you like to add it in now? Sure. So it's loading the toolbox. Bring in the ANSI inch. All right, so as we tunnel down into this group, we'll see pins, all pins, and then the different sizes. Do we want a hardened dowel pin, unhardened, standard dowel pin, spring pin, straight pins, tapered pins? No specification called out, so if we ever find number 39 in our roadmap, we'll pick it up. All right, so let's just go with an unhardened dowel pin, and I'm going to drag it from the window to the cylinder. And when I let go, it says, well, no matching size. Well, that's all right. We'll figure it out here. So it is 1/8 of an inch, and it is 1 inch long, and it updates the geometry as we go, and that looks pretty close to what I want. So we go ahead and accept it. And if one dowel pin's good, 100's better, so keep putting in dowel pins. No. We'll go with the one that we have. It picked up the concentricity. It may still be able to rotate. I'm not concerned about its rotation just yet. And to bring it up flush, we'll pick the end face and the cylinder and make it tangent. All right, and looks pretty close, so that makes our first assembly. All right, we'll finish up. We're not quite ready to go into the drawings. We'll finish up with an exploded view. Exploded views are not required for the assignment. But to go through the drawing, they're not really that difficult either. One of the things coming from different CAD backgrounds that you may have done is have separate files. There are not separate files for your exploded view and your standard assembly. The exploded view shows up underneath the configuration, and I can either right-click and go New Exploded View, or we go to the assembly, and under Assembly, Exploded View, and we'll click. I have to decide which item I want to be stationary. So let's go with the stud. All right. So when I click on an item, then I get the orbital. So we're not really rotating. I want to make sure that I get the arrow, and then I'm going to lift. Don't think that the auto spacing is on, and since I only selected one, shouldn't be that big of a deal. And then I'll grab the pin and pull it off to the side. All right. Any of those that I want to adjust the numbers, we can double click. 1 1/4 inches wasn't really that great, so how about 1 1/2? And apply it. Looks good. We'll go ahead and say done. Explode step 2. Let's go 2 inches. Apply, and done. Alright, so that gives me my exploded view. And when I go into the drawing, I can say access this exploded view. Well, I don't want to see the exploded view all the time, so when I expand out under the configuration, the exploded view is technically a sub-configuration. When we right-click and collapse, it goes back together. Right-click and explode, it comes apart. And if you want to see it animated, probably needed to reverse that. That would have been really cool to be able to do that. So it's going by the order that I created, but anyway, that gives us our geometry.